Hello class! Good day! Welcome to our online class. It's me, Teacher Edzon, your teacher in this session. Okay now, before we start, I would like to assure that you're ready in your comfortable place so you can focus in our lesson that we are going to discuss this day. So class, in checking our attendance, you just need to like this video so I can know that you already watched our lesson this day. For today's lesson, I will teach you on how to analyze motion. We have our objective. At the end of the lesson, you should be able to, number 1, make a visual representation of an object's motion. Number 2, describe motion through dot diagrams. And number 3, use graph in analyzing motion. Most accurate way to analyze motion is through the use of mathematical expressions. You have learned in the previous lesson how the equation for speed and velocity can be used in determining the behavior of a moving object. Aside from this equation, you will be introduced later to the idea of acceleration and its mathematical equivalent. But first, you need to learn to analyze motion using dot diagrams and motion graphs. You can analyze the relationship between distance and time using a ticker tape and a graph. A ticker tape is used as a recording timer. It is a narrow strip of a paper that is passed through a printing device and is attached to a moving object. As the object moves, the tape is dragged through the ticker, leaving a trail of dots. This trail of dots represents the object's motion. The distance between the dots represents the speed of the object at a certain time intervals. If the distance between the dots is large, it indicates the object is moving fast. But if the distance is small, it shows that the object is moving slow. You can also tell if the object is moving at a constant speed or not. Identical distance between dots represent a constant speed, while changing distances between dots shows that the object's speed is changing. So as you can see in this figure in letter A, constant speed is moving relatively slow. While in letter B, constant speed moving relatively fast. While in letter C, it is increasing speed. In letter D, as you can see, the speed is decreasing. That's how we analyze the speed of a object using a dot diagrams. How about in motion graphs? A distance time graph makes it possible for you to better visualize the motion of an object over a period of time. For example, if you plot the values in this table, the result will be the same in this graph. Time is shown the horizontal axis or x-axis, while the distance shown in the vertical axis or y-axis. The distance time graph represents the speed of an object. Notice that in 5 seconds, toy car covered 10 meter and in 20 seconds, it covered 40 meter. Thus, the speed of the toy car is constant at 2 meter per second. The graph representing the toy car's motion appears as a positive sloping line. The speed of the toy car can be obtained by calculating the slope or steepness of the line. When an object is moving fast, the line is steeper, that is in the blue line, compared to that of the slow-moving object, the one in the red line. If the object, like a parked vehicle, it is at rest, then there is no speed, so the distance time graph on an object at rest is a flat line with a slope of 0, that is in the green line. If the slope is changing, your graph is curved upward or downward. This means that the speed is also changing. As you can see in this figure, a graph that shows increasing speed. The speed of an object may be calculated from its distance time graph. The slope of the graph represents the speed of an object. The symbol delta means change. For example, is this. It means change in distance from a given reference point. So that's all for today about analyzing motion. Hope you have learned something from our discussion. See you in our next topic. Thank you!